Hi, this is Professor Sartor, and I'm going to work another 10 problems for my college algebra class. This question says, use the graph of a known basic function and a combination of transformations to sketch the function. Our function is g of x equals negative x plus 4 squared plus 3. So first, let's mention what the basic function is. Our basic function is going to be the square function because we have the square in our equation. So y equals x squared is our basic function. Now, if we don't already know what that graph looks like, we can plot points choosing x values and finding y values. So I would choose my standard set of points, -2, -1, 0, 1, and 2, and substitute those into the basic equation. So I'm substituting -2 in for x squared. -2 squared is a positive 4. -1 squared is positive 1. 0 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. That gives us a set of ordered pairs. -2, 4. -2, 1. Sorry, that's -1, 1. 0, 0. 1, 1. And 2, 4. I'm going to plot those points and see if a pattern emerges. We have 0, 0, 1, 1, 2, 4, -1, 1, -2, 4, and we can see the pattern that emerges as our parabola, with the vertex being at 0, 0. So that's going to be our basic function, our starting function. And then over here on our equation, we've got these different transformations. We have the -1, the +4, and the +3. So let's go one by one on these transformations. Let's start with the +4. So the +4 I know is a shift. And the reason why I know it's a shift is because it's adding and subtracting. Adding or subtracting of any values are going to give us a shift in the graph. Now that +4 is on the inside of the square, so that's going to make it a horizontal shift. Horizontal means left or right. So I know that that is a horizontal shift because that +4 is on the inside. And then, because it is a plus, I know that shift is going to go to the left 4 units. So the graph y equals x plus 4 squared will take this graph over here and shift every point to the left 4. So that would give me 1, 2, 3, 4 to the left via parabola, and instead of that vertex being at 0, 0, that vertex is now at -4, 0. Okay, so let's look at the next transformation. Let's look at that negative. So having a negative multiplied gives me a transformation of a reflection. So I know that that's a reflection because that is a negative that's multiplied onto our function. There are two types of reflections, horizontal and vertical. And because that negative is on the outside of the square, I know it's a vertical reflection. So because that negative is on the outside, that's how I know it's vertical. So a vertical reflection, vertical meaning up and down, you're going to take the top part of the graph and mirror image to the bottom, and that we're putting it over the x-axis. So this is a reflection over the x-axis. So thinking about our graph, now if we take y equals negative x plus 4 squared, so throwing in that negative, we'll take our graph and reflect it over the x-axis. So instead of it being an up-facing parabola, it's a down-facing parabola. Okay, so our final transformation, the +3, I know that's a shift because it's adding or subtracting. That is a vertical shift because that +3 is outside of the square. And because it is a plus, I know I'm going to be shifting up. Vertical is up or down, so I'm going to shift up 3. So my final graph, I have shifted left 4, up 3, and reflected down. So I get this picture right here. This is for y equals negative x plus 4 squared plus 3. This question says, let f of x equal square root x plus 3 and g of x equal x squared minus x. Find and simplify the expression. We have f plus g of 1. I want to find, f plus g of 1. There are two different ways I could go about doing this. I could first substitute 1 into f, substitute 1 into g, and then add my answers together. So let's try that first. Substituting a 1 in for f would give me square root of 1 plus 3, which is square root of 4, and that's 2. Substituting a 1 into g would give me 1 squared minus 1, which is 1 minus 1, and that's 0. If I add those two together, I get 2 plus 0, and that gives me 2. So that's one way to do this problem. The other way to do the problem is, since we're trying to find f plus g of 1, first I need to find f plus g of x. So this means I want to add the function f of x to the function g of x. That gives me square root of x plus 3 plus x squared minus x. And once we've simplified, and this is completely simplified since there are no like terms, I can then substitute the 1 into that function. So that would be 1 plus square root of 1 plus 3 plus 1 squared minus 1. That's square root of 4 plus 1 minus 1. Square root of 4 is 2. 1 minus 1 was 0. And 2 plus 0 is 2. So either way we get 2. Evaluate the expressions in A through F using the graphs of y equals f of x and y equals g of x. So we're given this g of x graph and this f of x graph, and we're asked to answer these questions. So with these questions, this is the operation of composition, g of f of negative 1, and we're just going to follow the symbols to find the answer for these. So for part A, it says g of f of negative 1. We're going to start with the inside. It says find f of negative 1. So on my graph, I want to go to where x is equal to negative 1, go up to the graph of f, and find the y value, which is 2. So f of negative 1 is 2. So I've replaced this f of negative 1 with a 2. So now I want to find g of 2. So I'm going to go to where x is 2, go up to the graph of g, and go over to get the y value, and that y value is 4. So g of 2 is 4. And then completing the problem, g of f of negative 1, that is equal to 4. Okay, let's try the next one. I have f of 0. So we're going to start on the inside, f of 0. Starting with an x value of 0, I'm going to go up to the graph of f, and my y value is a 1 there. I'm going to change f of 0 to be 1. Now I'm going to find f of 1. I'm going to go to where x is 1, go to the graph of f. I'm already at the graph of f, and the y value is 0 there. So f of 0 is 0. Let's try the next one. F of g of negative 1. So we'll start with g of negative 1. We have an x value of negative 1. I'm going to go all the way up to the graph of g, and the y value is 5. So g of negative 1 is 5. Now I want to find f of 5. Here's where x is 5. I'm going up to the graph of f, and the y value there is 2. So f of g of negative 1 is 2. Let's try the next one. G of 4. So we'll start with g of 4. Let's go to an x value of 4. Let's go up to the graph of g, over to that y value, and we get a y value of 4. G of 4 is 4. Now we want to find g of 4, which we just found. So having an x value of 4 going up to the graph of g gives us a y value of 4. Let's try the next one. The next one is, I'll write it up here. F of g of f of 0. So we're going to start off with f of 0. So I want to start with an x value of 0, go up to the graph, go up to the graph of f, and that gets me to a y value of 1. So f of 0 is 1. And I'll carry down the symbols on the rest of this. Now I want to find g of 1. So x value of 1, go up to the graph of g, and I get a y value of 6. G of 1 is 6. Carry down those symbols. Now I want to find f of 6. Let's find f of 6. Here's an x value of 6. Go to the graph of f, and the y value there is 3. So f of g of f of 0 is 3. All right, and we have our last one. G of f of g of 4. So starting with g of 4, we want to start off at an x value of 4, go up to the graph of g, that gives me a y value of 4. So g of 4 is 4. Now I want to find f of 4. I have an x value of 4, go up to the graph of f, and I get a y value of 1. So f of 4 is 1. So now I have g of 1. Let's find g of 1. An x value of 1, go up to the graph of g, and I get a y value of 6. So g of 1 is 6. Write the equation for the inverse function and then state the domain and range of f and f inverse. So first we want to find the inverse of f of x equals 4x plus 3 over 7. So I have a 3-step process that I'm going to use to find the inverse. So first I'm going to change that f of x to be y, just because the symbols are a little bit easier and y has more meaning to us. Then I'm going to switch the x and the y. This is what is making the inverse. Inverse functions switch their x and y values. And then I'm going to solve for y. So to get y by itself, I'm going to multiply both sides by 7. That gives me 7x on the left, and the 7's cancel out from the right. That leaves me with 4y plus 3. Now, I'm still trying to get y by itself, so I subtract 3. That's 7x minus 3 equals 4y. Then I'll divide both sides by 4, and I have y equals 7x minus 3 over 4. Let me correct my 4 there. Looked like a y. So this is the inverse of f. So we use the symbol f with a -1 to represent the inverse. So that's 7x minus 3 over 4. So we got the inverse function, and the rest of the equation is asking for the domain and range of our function and our inverse function. Now, the function f of x equals 4x plus 3 over 7 is a polynomial function, and more specifically, it's a linear function. And the domain of polynomial functions are all real numbers. So the domain of f is going to be -infinity to infinity. So we know that because it is a polynomial function. The inverse, remember, switches the x and the y. So the domain of the function is going to be the range of the inverse. So I know that the range of the inverse is going to be -infinity to infinity as well. Okay, so then I'm going to look at this function over here, the inverse. The inverse is 7x minus 3 over 4. That is also a polynomial function, more specifically a linear function. And so that's going to have a domain of all real numbers, or -infinity to infinity. And remember, like we said a moment ago, the x and the y values get switched. So the domain of the inverse is going to be the range of the function. So that's going to be -infinity to infinity. This question says, given the quadratic function in vertex form, address the following. We have a bunch of parts to work through here. So our function is f of x equals -5 times x minus 2 squared plus 5. And this is in vertex form. Vertex form is when you have f of x equals a times x minus h squared plus k. And that ordered pair, hk, is the vertex. Okay. So our function is f of x equals -5 times x minus 2 squared plus 5. And this 2 is, this 2 is in the same spot as h, and the 5 is in the same spot as k, making our vertex the ordered pair 2, 5. The next part says, does the graph open up or open down? And we can tell that this function, this parabola, will open down because of a. A is equal to -5, so my parabola will open down. The next part says, what is the equation of the axis of symmetry? So for a parabola, when you draw it, the vertex is right here. We have an imaginary line that goes through that vertex that's called the axis of symmetry. So it's called the axis of symmetry because if we were to fold the graph along that line, we're going to get a mirror image on both sides. So that's the axis of symmetry. And you notice that the axis of symmetry passes through the vertex. So we're going to use the x value of the vertex to write the axis of symmetry. So for this example, the axis of symmetry is the line x equals 2 because this function has a vertex at 2. The next part says find any x-intercepts. Okay, the way that we find an x-intercept is to let y equal 0. So for my function, I'm setting the f of x or y part equal to 0. I think I need to write down the function. It's -5 times x minus 2 squared plus 5. And I'm going to solve. I'm going to solve by isolating the square and everything it's attached to on one side. So I'll subtract 5 on both sides. That gives me -5 equals -5 times x minus 2 squared. Divide both sides by -5. That gives me 1 equals x minus 2 squared. Now that I've isolated the square, I'm going to get rid of it on both sides by square rooting. Square rooting will cancel out that square. And on the right, I'm left with the x minus 2. On the left, square root of 1 is 1. And I also pick up a plus or minus symbol because I square rooted that square. So then I want to add 2 to both sides. And that's going to give me x equals 2 plus or minus 1. 2 plus 1 gives me 3, and 2 minus 1 gives me 1. So those are my x-intercepts. X equals 3 and x equals 1. Okay. The next part is asking about the y-intercept. We find a y-intercept by letting x equal 0. So in my function, I substitute a 0 in for the x. That gives me -5 times 0 minus 2 squared plus 5. -5 times -2 squared plus 5. -5 times 4, because -2 squared is 4. -5 times 4 would be -20. And -20 plus 5 is -15. So we have a y-intercept of 0, -15. Then it says to sketch the graph. Let me come back up here to the graph. And we found this function has a vertex at 2, 5. 2, 5 would be about right here. We had x-intercepts at 1 and 3. And we had a y-intercept at 15. Should be here. And I'm going to connect these with a parabola, keeping in mind this vertex is a special point. That's where the graph is going to come to a peak. So we can sketch the graph. Okay, finally, we want to state the domain and range. The domain of every parabola is -infinity to infinity because this is a quadratic, which is a type of polynomial function. The range is going to start at negative infinity and go all the way up to that vertex, which was at 5. We're going to put a bracket on that 5 to include the 5 into the range. Okay, this question says, use the quadratic function f of x equals 2x squared plus 4x minus 5 to complete parts a through g. Use the vertex formula to determine the vertex. So the vertex formula is going to be h equals negative b over 2a. Now h is the x-coordinate of the vertex. And then we're going to find the y-coordinate of the vertex by substituting that value of h into our function. So our function is f of x equals 2x squared plus 4x minus 5. A is equal to 2, b is equal to 4, and c is equal to negative 5. So we're going to find the x-coordinate of our vertex by doing negative 4, that's negative b, over 2 times a, 2 times 2. That's negative 4 over 4, which is negative 1. So we've got the x-coordinate of our vertex being negative 1. Now we're going to find k, the y value of our vertex. We're going to substitute negative 1 into our function, and that would give me 2 times negative 1 squared plus 4 times negative 1 minus 5. So that would be 2 times positive 1, because negative 1 squared is 1, plus a negative 4 minus 5. That's 2 minus 9, which is a negative 7. So we have the vertex being the ordered pair negative 1, negative 7. The next part says, does the graph open up or down? So our value of a, which is 2, is going to tell us whether the parabola opens up or down. So our value of a is 2, which is a positive value. Anytime our a is positive, our parabola is going to open up. The next part says, what is the axis of symmetry? Okay, so when we have a parabola, looks something like this. The parabola has a vertex, and then there is an imaginary vertical line that goes through that vertex. And that imaginary vertical line is the axis of symmetry. We use the word symmetry because if we were to fold the graph along that invisible line, it would give a mirror image or symmetry on both sides. So the key takeaway there is that it's going to be a vertical line that passes through the vertex. So we're going to use that x-coordinate from our vertex of negative 1 to give us the axis of symmetry. So it's going to be the line, the vertical line, which is x equals negative 1. And that is our axis of symmetry. So the next part says to find any x-intercepts. The way that we find x-intercepts is to let y equal 0. So we're setting our function f of x equal to 0. So we'll have 0 equals 2x squared plus 4x minus 5. Let me try to factor this. So I would get 2x and x. Let me try 5 and 1. That would give me 5x. And 2x, which would give me 7. That doesn't work. All right, so let me try the 5 over here and the 1 here. That would give me 10x and 1x, which can't make the 4 that I want in the middle. So factoring is not going to work here, but we can do the quadratic formula to solve any quadratic function. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so earlier we saw that a was 2, b is 4, and c is negative 5. We'll substitute those values into the formula. That would be -4 plus or minus square root of 4 squared minus 4 times 2 times -5 all over 2 times 2. It's -4 plus or minus square root of 16. Negative and negative makes a plus, and that is a 40. So we have -4 plus or minus square root of 56. And I can factor 56 into 4 times 14. I'm going to go this way now. Square root of 4 is 2. The 14 stays inside the radical. I notice that these three values are even, so I can cancel out a 2 from each one of them. And that leaves me with -2 plus or minus square root of 14 over 2 as my x-intercepts. The next part wants us to find y-intercepts. We can find a y-intercept by letting x equal 0. So we're substituting a 0 in for x. That gives me 2 times 0 squared plus 4 times 0 minus 5, and that's -5. So we have a y-intercept of -5. Then we want a graph. So we had a vertex of -1, what was it, -7? -1, -7. We have a y-intercept at 1, 2, 3, 4, 5. And I don't know exactly what my x-intercepts are. You can figure them out in the calculator if you'd like, but I'm just going to guess. It will look just about like that. Remember that the vertex was right here, and we said we had an up-facing parabola. So from that vertex, we draw the parabola going up. The domain of this function is -infinity to infinity, and the range will start at the y value of the vertex, that's -7. We'll put a bracket on that -7, and it will continue, the range will continue to infinity. The price P and the quantity X sold of a small flat screen television set obeys the demand equation below. How much should be charged for the television set if there are 60 television sets in stock? What quantity X should maximize the revenue? What is the maximum revenue? What price should be charged in order to maximize revenue? Okay, so the first question says that this is the demand equation, P equals -0.11x plus 297. And the question says how much should be charged if there are 60 television sets. So that is our value of X, the number of television sets. So we're going to be able to find the price we should set, -0.11 times 60 plus 297. So let's do 0.11 times 60 would give me -6.6 plus 297. Do 297 minus 6.6. So 290.40 is what we should charge, $290.40. The next part says, what quantity will maximize revenue? Now, before we could actually maximize revenue, we need to find the revenue function. And there's a formula for revenue, a business formula, and that formula is X times P. So we need to find that revenue formula, find the revenue function. we were given the value of P, so we're going to have negative 0.11x plus 297. I'm substituting that in for P, and then I can use the distributive property, negative 0.11x squared plus 297x. That gives me my revenue equation. Now I'm going to maximize the revenue. What I notice here is that I have a quadratic. That squared tells me I have a quadratic, and then I have a negative coefficient. So my parabola will be a down-facing parabola, and the vertex is where my maximum will be. So I'm going to be able to find the maximum revenue by finding the vertex of this. So we'll use the vertex formula, which is h equals negative b over 2a. Our b is 297, or negative 297 over 2 times negative 0.11. So 2 times negative 0.11 will be negative 2.2. Hold on, is that right? 2 times 0.11, sorry about that. That's going to be negative 0.22. Negative 297 over negative 2.22 gives me 1,350. Okay. So then I can find the k part of the vertex by substituting that 1350 into the revenue function. Negative 0.11 times 1350 squared plus 297 times 1350. Okay, let me put that in my calculator. Negative 0.11 times 1350 squared plus 297 times 1350 gives me 200,475. So let's make sure we know what those values mean. For our equation, this x represents number of units. So this 1350 will be the number of units, and this 200,495 will be our revenue. So we get a max revenue of 200,475 when we sell 1,350 televisions. Then the last part, what price should be charged? So we can substitute in for our price, our demand function, negative 0.11x plus 297. We'll substitute x into that, 1350 plus 297. So I'm going to do 1350 times 0.11. Negative 0.11 gives me negative 148.5 plus 297. And I get $148.50. $148. No, that's not right. Okay, let me fix that. Hold on, I'll double check. 297 minus 148.50. Yep, that's right. So our price that we should charge to maximize the revenue is $148.50. All right, use the graph to show and find the following. So in this graph, what I see here is a rational function, And these red dotted lines are the asymptotes. We have a vertical asymptote that's happening at 2, a horizontal asymptote that's happening at -2. Asymptotes are where the graph gets closer and closer to that value, but never actually reaches it. So on this part of the graph, the line is getting closer and closer to a value of -2, but never reaching it. Over here, this is getting closer and closer to a value of 2, but never reaching it. So if I want to find the domain, I'm going to use my ruler, hold it vertically. You can use your pencil. And I want to sweep from left to right. And I'm thinking about when is the first time I hit the graph. So my domain would start there at -infinity. I would keep hitting the graph until I get to this asymptote. Remember, the graph never reaches that asymptote, so the graph will never reach that value of 2. So my domain has to stop at 2. But then right after the asymptote, it picks up again on this part of the graph. So you start hitting the graph again from +2 to infinity. You could also say that x is not equal to 2. That's another way of saying what the domain is. Let me write that a little bit more formally in what we call set builder notation. It would be x such that x is not equal to 2. The other notation I used is called interval notation. So then we want to find the range. To find the range, we would hold our pencil horizontally, our ruler horizontally, and go from bottom to top. And we would start hitting the graph at -infinity. So our range starts at -infinity. And then we're going to keep going up until we get to that asymptote. Remember, the graph is never going to reach the asymptote, so it will never reach a y value of -2. So our range stops at -2. But then right after that asymptote, we start hitting the graph again, and that goes all the way up to infinity. So our range would continue from -2 to infinity. So another way to write that is set builder notation. We would say y such that y is not equal to -2. Okay, the next part is asking for intercepts. So an x-intercept is where the graph is crossing the x-axis. So I can see this value right here. The graph crosses the x-axis at that value, and that is at 0. So we have an x-intercept at 0. Then we have y-intercepts. The y-intercepts is where the graph is crossing the y-axis. And we have that happening also at 0. We have a y-intercept at 0. I already mentioned that this graph has a horizontal asymptote. The horizontal asymptote is this horizontal red dashed line, and that is the line y equals -2. So we have a horizontal asymptote on the line y equals -2. We also have a vertical asymptote. That vertical asymptote is this vertical red dashed line, and that's happening at the line x equals +2. So our vertical asymptote is x equals 2. An oblique asymptote is if we would have a slanted dashed line that our graph might be approaching. But we don't have one in this picture, so there is no oblique or slant asymptote. This question says, find all vertical asymptotes and create a rough sketch of the graph near each asymptote. So our function is f of x equals x plus 2 over x squared minus 9x plus 14. So before we find the vertical asymptote, we have to make sure that our function is in lowest terms. So that means that we want to factor our denominator and cancel out any common factors that we have. So our denominator, which is x squared minus 9x plus 14, is going to factor into x and x. Factors of 14 are 7 and 2, and I'm going to make them both negative. And that is the correct factorization. You notice that we don't have any common factors, so I'm going to have vertical asymptotes at these two factors. So you're going to find them by setting each factor equal to 0. So we're going to have a vertical asymptote at x equals 7 and another vertical asymptote at x equals 2. So we have vertical asymptote, x equals 7, a vertical asymptote at x equals 2. So we can kind of eliminate A and B because A doesn't have a vertical asymptote and B only has one vertical asymptote. So we want to narrow down our sketch to be one of these two pictures. So when we have our asymptotes, let me draw them. We're going to have at 2 we'll have a vertical line, and at 7 we'll have a vertical dashed line. Those are going to be where our asymptotes are. Now vertical asymptotes will have your y values either going to infinity or negative infinity. We don't know which one, and that's why we need to figure out how to sketch the graph, whether the graph will go to infinity or negative infinity. So what I mean is if I go on this side of the 7, my graph might be going up to infinity like this, or my graph might be going down to negative infinity like that. I need to test it out to see which is which. So the way I test it out is just by picking a value that is slightly bigger than 7. So since this is 7, I'm going to pick a number that's just a little bit bigger than 7, like maybe 8, and see what's happening to the y. So if I figure out f of 8, that's 8 plus 2 over 8 squared minus 9 times 8 plus 14. That gives me 10 over 64 minus 72 plus 14. Okay, 64 minus 72 is negative 8 plus 14. It's 10 over 6. That's a positive value. So because that comes out to be a positive value, I know the graph is going to go to positive infinity. So I know that this part of the graph will go to positive infinity. Then I need to know what's happening on the other side. So 7 and below 7 would give me 6. So let's find f of 6. 6 plus 2, 6 squared minus 9 times 6 plus 14 would be 8 over 36 minus 54 plus 14. That's 8 over 36 minus 54. Negative 18 over 14. That's 8 over negative 4. This comes out to be negative. So because it comes out to be negative, I know this part of the graph will be going down to negative infinity. So then I need to know what's happening on either side of the 2. So I'm going to plug in 3 and 1. F of 1 is 1 plus 2 over 1 squared minus 9 times 1 plus 14. That's 3 over 1 minus 9 plus 14. That's 3 over negative 8 plus 14. It's 3 over 6. That's positive. So I know on the left side of this asymptote, that's going to go to positive infinity. And let's see what's happening on the other side. F of 3. That's 3 plus 2 over 3 squared minus 9 times 3 plus 14. It's 5 over 9 minus 27 plus 14. That's 5 over 9 minus 27. That's negative 18 plus 14. That's 5 over negative 4. That's a negative, so that's going to go to negative infinity. So on this side, it goes to negative infinity. And that matches graph C.